Good evening, everyone. Thank you for having me here. A couple of introductory comments. As Ian mentioned, we know each other for very long, and way before any partnership started in my hometown of Mariánské Lazy, and this is because I spent a couple of years in Britain working as a postdoc, and at those times I was involved in a MOD project which was actually solved here at DERA. And from Cambridge, I used to come here for management meetings. That's when we met for the first time with Jan. And then after that, I moved back to my home country and continued the career of computer scientist. And after a couple of years, I moved to industry. And then actually, initially, like my science career was about computer science in general and machine learning. And then when I switched to industry, I got involved with cybersecurity quite heavily. So I mentioned here that I worked at Cisco Systems. Now I work at Gen Digital, which is a completely unknown name, but let me explain what that means. It's if you have ever heard about antivirus software like Norton 360, Symantec Security, AVG, Avast Software, or Avira. All of those that I have just listed, actually these companies have merged into one giant company called Gen Digital, so that's it actually. And this is now a company that holds something like 40-something% of the global worldwide market with consumer security software. So from what capacity I'm talking here, I happen to be the head of the AI research team in that company, which means that as these whole companies merged, they also merged the technology to some extent. So basically, it was about taking the best of all of these products and putting them to the core of the protection technology behind those products. We call this engines. So the company maintains its engines, and part of the functionality of the engines is now due to artificial intelligence, and it is my team that develops that and maintains that. So, and part of my let's say, long-term interest in computer science and now in artificial intelligence, it is all about, for me, about understanding where did the computers come from, how they look like now, how they will look like in the future. And lately, also, for a long time, it seemed to me that computers were just a tool that you could use for your daily business and that would be fine. But after 2000, let's say, computers are becoming more and more involved in society, how society works, and they bring positive and negative things, and artificial intelligence amplifies that to quite a lot. So that will be part of what I will be talking about as well. So let's say, let me start from a kind of look back, where it all started, as far as I can tell. There is one interesting question. How old would you guess is the known machine that can be called a computer? With a grain of salt.
The Babylonian period.
Well, we don't know anything about machines from that time. We know that they were really good at mathematics. They probably were faster than the Greeks in discovering Pythagoras' theorem and stuff like that. And but speaking of something that actually computes, really. Yeah. So I think this is the oldest thing that is known to mankind. Maybe you may know something older, but if you haven't heard about this one, that's a really crazy story, and I recommend you to find for yourself more details. This machine, that's a reconstruction, because like what was really found was this, like completely corroded pieces of wheels. What it does, it's like a very complicated, let's say, watchwork, something similar to a very complicated watch. And the Greeks used it for predicting all the planetary movements and some other details of when to organize the next Olympic Games and when some Egyptian religious calendar events should happen, depending on the position of planets and all of these things. And it was encoded in this absolutely amazing thing. And it is amazing also because if you look further, the next big thing that I could discover, 16th, 17th century, so there was actually an enormously long period of time when not much had happened. There were things happening. There were things happening in Baghdad, for instance. But they were probably not building machines. They were thinking about how to write down procedures of solving some problems. Yes, also the word algorithm comes from Arabic from those times, for instance. But speaking of machines, here we have a mechanical calculator. Another interesting, very interesting moment in the history for me is 1850s. Charles Babbage, here in England, built a, let's say, much more capable machine, computational machine, more capable than the previous one that I showed. But here, I refer to Ada Lovelace, and that because she is probably the first person who realized that it is good to have a machine that can compute, but it's not just one purpose, it's to have it reusable for solving different things. And how to make it solve those different things, you need to encode, actually, somehow, what it should do. And the mere idea that you will take some kind of programming language and encode it into the machine, and then the machine will do something what you want and something else, that's her idea. And also, accordingly, in the 60s of the 20th century, one of the very first real programming languages was called Ada in her honor. And here comes the, let's say, really breakthrough time. Right after World War II, 1948, Claude Shannon actually was the person who realized that if you start computing in zeros and ones, if you turn everything into binary computation, then you have the best chances, and then he has proven that this is the optimal way how to use your resources, your computing resources. Before that, people experimented with analog signals and whatnot, and it wasn't possible to compute much. You know, definitely not with mechanical machines, and then with these analog ones, still nothing too great. But he was able to prove all sorts of things about the power of encoding stuff into zeros and ones. And that also opened up all the way forward for building the computers. And from this very same period, your own Alan Turing also, let's say, coined the basis of computation as we know it nowadays. So his importance really can't be overstated. This is he was able to prove what is possible to be computed using a machine that encodes things into zeros and ones. Let's put it like this. Yeah. So, and he has also proven mathematically and correctly some of the limits of what the computers can do, which is another absolutely amazing thing. Yeah. And that holds until now. And for you, an example of what he was able to prove, if you wanted to have a computer program that would analyze another program and answer the question for you, is the other one correct? Yes or no? And that can be done, actually. Or will the other one ever stop if you launch it? Again, it can be done. So some very interesting things. Regardless of anything you hear now about artificial intelligence or not, these laws can be broken. So absolutely amazing results on his side. He's also known for the Turing test, which is a kind of, he basically just said, proposed to evaluate whether the machine is intelligent by having it, let's say, blindly communicating with someone that someone doesn't know whether it's communicating with the machine or not, and just if it appears human enough, then it can be called intelligent. I think that definition nowadays, I would be careful about it, because like this Turing test has been passed now with the current artificial intelligence. You have models that I think pass this test, but still I would claim they aren't intelligent, and we will get back to it. Now, so I mentioned the 50s. In the 50s of the 20th century, there came also this extremely important thing from Frank Rosenblatt, 1957, who actually came up with the idea of a perceptron. This is inspired from what we have in our heads, how actually our brains work. And we have neurons in our heads, they are connected into very complex structures. And basically the perceptron is how to encode into a computer one neuron, so it's nothing else. And he studied that and came up with a definition of what it does actually. And so that's some of the, let's say, beginnings of machine learning and beginnings of artificial intelligence. But before I comment on these crazy pictures, why I have them here, I first will comment on the column on the left, because that's a note about a, let's say, long-standing argument between two groups of scientists, which I say that it's coming from the 70s. I think it's earlier than that, but I have experienced that myself in my communications with my colleagues in the past. So, okay, there is a group of computer scientists who claim that any artificial intelligence should actually be based on logic, that it should encode in some way the reality, and it should be encoded using logical rules, possibly, or something that really captures the ideas behind things. So that group of computer scientists, I would call them Platonists actually, like after Plato, because this is very similar to that expectation. And the other group are statisticians, who basically say, okay, it's nice to want to have the understanding of the real idea behind things, but it's not possible anyway, so we don't care. Just give us data, and we will learn something from the data, and we will just try to predict what will be the next measurement. And we don't care why. It's like, as long as it is useful, as long as we can predict, then fine, we are fine. And these groups have been arguing for very long. And when I started my professional career as a scientist in the Czech Academy of Sciences, that was present there. These groups still kept fighting, but already by then, in the early 90s, it was, I think, almost clear that the logicians don't have much chance because they didn't achieve much, let's say. There is a notion of an expert system, and some have been built, but it didn't go anywhere as far as the current wave of artificial intelligence, which is purely statistics, basically. So here I say statisticians so far they win, but it also means that the technology that is now behind artificial intelligence is like heavily statistical, and by definition in itself it's not defined to really reveal, let's say, the real substance of the world, if I may put it like that. They basically search after patterns and somehow combine, analyze and synthesize patterns, and there is lots of value. We already know, and I will get back to it. But this technology of artificial intelligence that nowadays is like extremely useful, it goes back to the idea of the perceptron. Now, what I illustrate here and why, because I like to remove this feeling of magic that some people feel about artificial intelligence. I know that people sometimes think that, oh, there is something really like say, intelligent or behind the technology, something unfathomable. And well, to some extent, yes, but it's not magic. It's the core when it started, it looks like this. And what I'm illustrating here is the simplest possible machine-learned model that you can imagine. I'm trying to explain here how you can actually build a machine-learned model. Okay, I switched the words. I was talking about artificial intelligence. Now I use the word machine learning. Machine learning is a subset of artificial intelligence. Let's put it like this. Yeah, it's one way how to learn from the data and get something that predicts and gives you value. Artificial intelligence has all sorts of ambitions beyond that, but as it turns out, most of that is still like around machine learning and some more complicated, let's say, forms of it. But what happens in machine learning? What happens when you teach a computer to recognize something? So here, this is an example of the task that you want to teach the computer to distinguish cats from dogs. Now, the computer is absolutely stupid. It just uses zeros and ones, and it's good at processing numbers. But you need to somehow explain it actually, like how you need something that will transform the objects that you want to classify into numbers. In the original, let's say, shallow learning paradigm from the past, it was humans who needed to somehow transform the information about objects of the real life into numbers so that the computers could do something about it. Here, I assume that I, as a human, would say, okay, so I want to classify dogs, I want to classify cats, and I need some numbers that describe their properties. So what numbers could that be? And so I say, okay, maybe size, that might help. Maybe the level of domestication, that might also help. And I can invent more, actually. And now I start to collect examples. That means I need to be shown real cats, real dogs. And here what I show, the first image. So I have been shown one dog, one cat. In both of those, I somehow measured those two numbers. And I put them on a plane. So I drew it as a piece of paper. And so here, that basically on that image, you see that I claim that that dog that I have seen is big, relatively, the dog is relatively small, and the dog seems to be a bit more domesticated than that cat. So the two numbers basically are distances on those axes, and you put basically just dots on there. I put there the images, but thinking dots. Yeah. And then the learning process means that I see more examples. So someone brings me one more dog. So I measure it, the numbers look a bit different, so I put another dot over there. And I continue actually adding dogs and cats. And at some moment, what happens, I try to actually find this line which somehow distinguishes on my paper the dots that represent dogs from the dots that represent cats. And that line will be the classifier, that will be the result of the learning. And I can actually just remember that, okay, that line, if it is shifted from the base by a certain number, and if actually the angle is again a certain number, which I have learned, these two numbers, that's the result of the learning. And why? What can I do with it? Because from that moment on, if someone shows me, I switch the whole thing from learning to application. And here comes someone with a new dog, which is completely different from the previous ones. They tell me the numbers, and and the computer just looks at the line and looks whether the dot would fall to the right of the line or to the left. That's just that. So if it falls to the right, it will tell, okay, so it's a dog. If it would fall to the left, it would say it's a cat. And simply because it somehow assumes that that's a statistical thing. Because most of the dogs actually appear in that part of the paper. Most of the cats appear somewhere here. So basically, when I apply that learned model, which is basically in here, it is just the slits in the line. It basically encodes this information that if the new example fell here, it would be probably a cat. Now, this sounds really stupid, and but it is surprisingly powerful if you somehow continue doing this, and if you, the real models that we really use so many more clever techniques, but the basis is roughly this. And I should also point out one more thing. If someone would be cunning enough to come to such a computer and show it an elephant, it would have no idea what an elephant is, because I would get just the level of domestication and size. And the size would be, of course, really big. So it would be to the right of the line, and the computer would say, oh, that's a dog. So that's a great example, actually, of how you can completely fail in learning or training the computer, these machine learning models, to do what you exactly want. So in the let's say, early years, when everything depended on humans actually collecting all the data and describing it with enough numerical values. Here, if I knew that there might come an elephant, I could add actually a third axis here, and the axis would just say, does it have a trunk or not? And it would be like 0, 1, and that would already help me. And then, in 3 axes, of course, it would not be about a line, it would be actually about a plane. Then I would learn how to move it around. And so you see no magic. And actually, all the models that exist somehow do something similar, although in an extremely more complicated way. But I can tell you that I myself am surprised how powerful the mere statistics can be. If you don't use just 2 axes, 3 axes, if you have thousands of axes, and if those axes are actually like defined also by the computer, which can be also learned from data in a slightly different way, but not too complicated, too different. And if the number of examples is in billions, then the power of this principle becomes really, really surprising. I would put it like this. Machine learning paradigms, what I just illustrated about the dogs and the cats, is what we call supervised learning, because I supervised it. I told it always, like, this is an example of a dog, this is an example of a cat. So it's about solving the classification problem. In machine learning, you have other types of paradigms. You can use unsupervised learning, where you don't tell it what it was, you just measure. And then you ask the computer to tell whether there are possibly some groups that may be similar to each other or have some characteristics. So you can use it as a statistical tool to analyze the data. Reinforcement learning, 1998, is a much newer, actually, the third, let's say, leg of machine learning paradigms. Learning from mistakes in games. That's by Roger Sutton, and that's an important addition. It's basically a paradigm where really games are played, and the computer observes how it goes. And when one side wins, the other side loses, then the computer somehow records the flow of play and tries to extract patterns that might be correlated with winning or losing. And if you repeat that, the machine somehow reveals or learns how to increase the chance of winning. And when I talk about games, don't think just about games as we play, like I don't know, board games or whatnot. This is about real situations in the real life, because like the game theory, although it is called game theory, it's really about solving problems. It's about navigating your way in mazes, or it can be much more useful, and I think I will have some more examples where it actually made the change. Okay, so these paradigms have been with us at least since the 50s, except of reinforcement learning. But after the year 2000, roughly, here comes the era of deep learning. Some breakthrough, let's say, results have been achieved. If I may summarize it all into the simplest possible explanation, they succeeded in removing the human step. Because in my example with dogs and cats, that example depended on me telling the computer, measure the size and measure the domestication level. And that is extremely limiting, because if you want to apply computers to some kind of data which is not exactly human data, your intuition may fail you. So the real informational content can be different. Deep learning means that people have succeeded in modifying the learning process so that even this can be learned. And that's a fascinating thing for me as a computer scientist to observe, because specifically in computer vision, which is a field which has been with us for maybe 40 years at least, where people tried to build software or models, if you wish, that would allow analyzing photos and content of photos, or basically visual information, for all sorts of reasons. You need nowadays it is used everywhere for face recognition or license plate recognition, so things like that. Lots of results have been achieved over the 30 years until 2000. And that was, most of the power behind that was about people thinking or defining how to transform that visual signal into numbers for the computer, so that the statistical tool can be used. And deep learning actually made that completely obsolete. That was absolutely fascinating. Like the convolutional neural networks here, at the first attempt of learning from data, they just, you see, it's made really irrelevant all the results before that. They just became like, if the best accuracy achievable before was something like 85%, yeah, in recognizing human faces, this convolutional neural network suddenly would jump to 98% at the first attempt, and then you can tune it. And so this principle of actually making the machine use all the data itself and interpret the data as much as possible itself, then you can achieve much more. This is like the example on the left, where you see the car. Underneath there is a multi-layer neural network. This is all about neural networks. On to the right from the car, there is a number of little images which show something like differently angled, you see, edges or something, and the third one, the third block has something more, let's say, varied. That's the result, that's the visualization of what the model itself learned about bits and pieces in the image that are actually important to distinguish different car manufacturers, for instance. And it's hard to interpret for us, but I don't care, it's simply, that's the statistical approach. You just want the result, and here the result is the model is good enough to recognize the car, what it is, license plates, etc., etc. And how it does internally is not that important anymore, because this is still, the principle is still very well understood, what's happening inside. Now, so far I've been talking about like capabilities of computing and how we learned to teach the computers, or to have the computers learn from data. That implies we need the data, and I have here actually some commentary about how our civilization has been producing more and more data. I think that archaeologists agree that probably at the moment when they started to record something on the tablets, it brought some important changes in their societies, because it made it possible to organize a bigger society somehow. 1440s, Gutenberg press brought the next level of democratization of information, let's put it like this. Because printing the book meant that many more people could read a book. Of course, assuming they could read at all, but the availability of books as probably the primary carrier of information at those times. Then 1700s until 1800s, the slow start of printed newspapers. If you think about it, when you compare the emergence of newspapers compared to books, that just accelerates the sharing of information. Suddenly you have weekly updates or daily updates. It brings, let's say, more information, probably less permanent. Here comes radio with much more reach again. Here comes TV. In the 1990s, internet, email. In the 2000s, social networks, social media. So we are now flooded with information. So this is basically what the ordinary citizens are exposed to. There are some other, of course, sharing mechanisms for information within scientific circles. Of course, you have specialized data and etc., etc. But let's put that aside. So this is also kind of important together with our evolution, or with our advances of machine learning / artificial intelligence, because we have much more data than ever before, and now we have technology that can learn from data. So that helps each other, of course. This is a side note, this observation of mine, that actually whenever there came a really significant, let's say, advance in information sharing, it took some years of turmoil in the past. So I'm now bracing myself for this current period, because the social networks and social media really seem to be extremely influential on our societies, and I don't think that we have learned how to deal with that so far. I think I will get back to this topic because it goes back to how the internet itself has been designed, and it definitely has not been designed for that wide use as it is used now. Okay, so digital history of civilization, that was my summary. Now, AI for better or worse, what I mean by that, you will see. Let me summarize where we are now with AI, how I see its pluses and minuses. This section is about that. So here is a summary of where we are now, what is the latest, let's say, developments in frontier AI. So far I talked mostly about machine learning, which is about learning from data and getting a model, which can be that single line or something a bit more complex. A couple of years ago, there came one breakthrough. As it happened, it was in Google. They published a paper called "Attention is all that means," I think, some roughly like that. The technology they brought in was called Transformer. It doesn't come totally out of the blue. It's not like something absolutely novel, but it made certain computations much more effective, and it made it possible to train really large language models. And until then, no one kind of realized how powerful actually a language model can be. Language model, what I mean by that? The models I mentioned before, classification ones for distinguishing cats and dogs, these were designed basically for that purpose. I needed to classify some object, okay, so that was the purpose of the model. Language models use a slightly different way how to deal with data, but they can process a lot of text, and let's say that the basic idea usually was to taking some window of context, which may be a sentence or a couple of words. You are interested to predict what will be the next word. That, what I just said, makes it possible to apply almost the same technology as I described with dogs and cats. It's very similar. It basically classify, okay, so which will be the next word. Of course, nowadays it is much more clever than this, but the basis roughly comes from that side. And people learned that if you do this, you can observe very powerful, let's say, properties of these models. If you train them from a really large body of text, you can predict the next kind of flow of the text, and for a long time it looks like it looks like written by a human actually. And as that was one big kind of change, this speed of training, and that allowed these companies like Google, but OpenAI is the primary one, that allowed them to actually feed more and more data. And suddenly they realized that they can take all the data from the whole internet, feed it into the models, and they were just interested to see what will happen if you create such a big language model. And it started to look really interesting because it started to be useful almost as if you communicated with someone. When I try to explain what's happening in these big language models, I have slightly stupid analogy, so apologies for that, but think of that model as, I imagine a very young child that doesn't understand anything what's happening around, but has a perfect memory, absolutely perfect memory. If a CEO of a company would bring the child with her or him all the time to all the meetings, all the managerial meetings, and the child would just remember everything. Then, in the future, and if you would be doing it for really long, and then try to ask the child some difficult managerial question from a different company, it will somehow think in the memory, okay, so without actually understanding what the question is, what is the substance? It would just somehow think, oh, what is the similar? What have I heard in the past? What was somehow similar? Oh, they were talking about something similar somehow, like there. let's put together like this information from those previous conversations and throw it up. That sounds really stupid, but here comes the power of the big statistics. If you really do it on all the data that humankind have ever produced, then the chance that you will get something really good is enormously high. It's surprisingly high. And I think that we all are surprised whether you tried ChatGPT for almost whatever. You get surprisingly good answers. But there is definitely no intelligence as such, as far as I can tell. But that's a different debate, and you may challenge me afterwards. Yeah. Okay, image video. People started to. There is also some advance on the level of generating images, not just text. I will not go into the details of that, but then people came up with combining into the same model text, voice, video, whatnot. And that is great, because if you have a model that kind of has been trained from all of these types of data, then you can instruct it in, I don't know, in voice, and you can ask it to generate images, or vice versa. And so in the end, these biggest models that we have, we don't have, but that we can use, I view them as extremely powerful databases of all the human kind of data that humans produce. And databases that are way better than just returning like simple answers, okay, is there any data like that or not? The ability of the model is really to synthesize, to somehow, mash up the information and come up with something which is with very high probability what you wanted. And here, agentic AI, this is like everyone talks this year about agents. That's a topic in itself. I could spend a lot of time about this, but let's put it aside. But two things are happening this year. One is the agentic AI. The other one is reasoning models. So the big producers of these models claim that they now have reasoning models. It's not, let's say, true reasoning in the sense that we do. I can get back to it if you would be interested afterwards. I can comment on what I know about it. Of course, my knowledge is limited. Yeah, I'm not from those companies that produce these big models. So my experience comes from being a corporate user of those models, who is supposed to use them for the good of our customers. And that means that I must be extremely careful about how I use them. And that also means that my people spend an enormous amount of time evaluating and guardrailing and doing all sorts of things to prevent mistakes. And that means also that I have seen a lot of mistakes from the current AI, probably more than you would see when you just play with them. So that's where I come from. Okay, I have here a commentary about what is my intuition about how the AI works. And I actually mentioned some of the intuition already. Because it's still a statistical tool, what it also means, it depends on the data from which it has been trained. Now, what to make out of it for you? If you use a language model, you communicate with it, if you ask it for answers that are commonly asked, that are on topics that people are exposed to worldwide often, and likely there has been quite a lot of material on the internet about the topic, then the chance that you will get a good answer is really high, surprisingly high. But the more you go into fringe questions, somewhere where the model has not seen enough data during training, then it will start to, let's say that the confidence of the model will decrease, but you will not know it because it will still communicate completely to you. It will look as confident as ever, but in the background, inside, it will start to kind of fabricate things because these things will not be enough well-grounded, let's put it like this. So this is the comment here. The more you steer the model towards fringe, the higher the chance of mistakes. And that holds still with these current best models, with the current best technology that we are offered. On the level of computer languages, for instance, I can tell you, because we use it for coding, there is this big claim that artificial intelligence will replace computer programmers and engineers. It hasn't happened. So far, it does help during the work. It can help a lot, and it helps with the most repetitive parts of the work. And I'm happy to see that, because it confirms this intuition. Yeah? Because the most stupid parts of the work are the most common, yeah, if I may put it like this. But at the same time, the engineers in my team have this experience that if you try to steer it to generate pieces of code that is really some special and there is lots of your own conditioning that you put on it, then after some moment it starts to hallucinate, as we put it. So it completely fails. Yeah. And this is still the current state, even with the best models available. And here I touch the question, what is artificial general intelligence, AGI? That would be speculation from my side. I think that it's now very popular among the investors to talk about it, and also for journalists, because of course, if you think that you would get technology that is as good as humans or better in basically any field you can imagine, then that would be probably a problem. From what I know about the models, yeah, I don't see anything that I could call an intelligence. Don't forget that many techniques, even 20 years old, 30 years old, the computers, are already better than humans in certain things, and we don't fear them. Like the specialized programs that play chess have won over the chess masters, again, 20 years ago. And I have no reason to fear that technology, simply because it is so narrow. So I understand that there is that people may be afraid of a general intelligence if that is something that is better than us in everything. I think the real question is the question of conscience. Will there be any conscience in the machines? My feeling is that not. I can't be sure, but from what I know about the technology, no. There is no conscience in none of those models that I've been exposed to. I think I'm not alone in this feeling. If you are interested in some much more clever debate, then you can find on YouTube Roger Penrose's argument. Okay, so now let me just browse through a couple of other notes. So this slide is meant to show how much good actually AI machine learning can do. So there is an extremely high potential. Why I'm putting it here? Because the other slides that will follow come from my cybersecurity background, so they will be much more on the negative side. So I just needed to so take it with a grain of salt when I will be then talking about all the dangers and these bad things. So that's simply because it's my profession. So I just wanted to put here some kind of grounding that I'm not person who would say that all the technology is bad, because I see how amazing things can be achieved. One single thing that I would point out here that really made me happy actually about this advance in artificial intelligence, that is a Google project called AlphaFold, written here. It's used for predicting. I don't have the exact definition in my head, but the problem they are solving is this. There is hundreds of thousands, I think, protein types that exist. Many of them, have the potential to be used in drugs and to cure diseases which we can't cure at the moment. So far, since, I don't know, the half of the 20th century, many laboratories worked on sorting out all those hundreds of thousands of proteins. And there are techniques that can tell you whether a protein has the potential or not, but ultimately you need to try, you need to actually do the chemistry work. And one of the biggest problems was how to reduce the number of possibilities. So there have been softwares or programs that try to do that. But AlphaFold made this several orders of magnitude more efficient. So I understand that before Google tried that, still most of the options were not explored. Now with AlphaFold, this is basically served to the scientists in chemistry on a golden plate. So it's now they can focus. And what that means, I expect that in the single years to come, we will see some unbelievably efficient drugs to cure cancer and whatnot, Alzheimer's and whatnot. So in this sense, we are in an absolutely amazing time, and some of the most important, most interesting times in history, from my perspective. And when I say Google, I meant DeepMind actually. That's the Google is the parent company of DeepMind, and I think that DeepMind is stationed here in Britain, if I'm right. And some similar advances can be observed in the other fields. Here is the note of about how you can use AI nowadays, because there are free versions, of course, of the large models that people can use. I will get back to the word free, because nothing is free on the internet, but let's say that you can install the app and you can start using it. I'm not sure whether you have tried to what extent you have tried, but I'm putting here some examples that give you surprisingly good results. These are the type of things that I use these models, let's say, on a regular basis for my own purposes. If I want to, here are the remarks. That is actually a list of remarks from me from my own experience, but I think that many have made a similar experience. When you formulate, when you communicate with the model, like put there this instruction. Let's say that human language is not necessarily the best option to instruct a machine what it should do. But these models are so popular because they use human language, and that's why everyone can formulate. So the advice is be as precise as possible and clear as possible. Any ambiguity would confuse the model and would give you something unexpected, probably. Some very interesting experiences is like okay, specifying persona. Yeah, you can tell the model, okay, so from now on you are head physician from, I don't know, this famous hospital, and I want your opinion about something. And you will get probably a much better justification for what counts. But this is a bad example for me, because asking about things like medical advice, that's exactly what I would not rely on because of hallucinations. Because I know that these models, they are statistical models, they don't give guarantees. And maybe I can surprise you by one thing. From my experience as a corporate user of these models, where we actually use the APIs, we somehow use these big models in our solutions for our customers, and that means that we don't use the same models that are exposed to the general public. Of course, we use those that are supposed to be much more controllable and configurable, etc., etc., and we have agreements with them. In these, they never agree for any liability for accuracy of what the models return. And so all these providers like OpenAI, Google, Meta, XAI, they all know how experimental the whole thing is, and so they keep even repeating that in these agreements. And so that's why it's actually difficult for us, let's say ordinary people, to be exposed to something that gives you surprisingly solid-looking results and surprisingly useful results. For a long time, you will be using it for days and days, and you will be getting extremely good results. But that is confusing, because you would suddenly feel like, okay, I can trust it. And that's the mistake. Because 99 times it will be absolutely perfect and amazing, and the 100th time it will still look confident, it will still look valid, it will look absolutely perfect to you, but it will be absolute rubbish. It will fabricate laws, for instance. It will fabricate publications. It will fabricate persons. That's the statistics behind it. And so far, the producers of these models have no way how to do this principally right. They keep improving the models themselves, and they keep actually improving them also with some sorts of guardrails and whatnot, but principally it is not solvable at the moment. And here I switch to the bad things, because I'm from a cybersecurity company. So this is on the left, there is a little history of how people came up with ideas how to do something bad on the internet. What I have here on the right, this is the current state. Let's say that who are the malicious actors? Well, who are the people who try to do some bad to you? Let's say that a large number of those are hackers, or it can be one person, it can be 1 to 3 persons who find themselves over the internet somewhere, and many current, let's say, scamming campaigns come from people like that. Because unfortunately, also AI helped to democratize the access to the bad software. Yeah, so nowadays you can actually buy a virus at the dark internet. You can buy software that generates viruses for you, and then you can spread them if you wish. You can do all sorts of things at the dark net. There are specialized versions of GPT, like ChatGPT. There is something that is called Dark GPT, and at least a dozen of others, which are again available at the dark internet, and you can use them. You can ask them for all sorts of really nasty things, like how to steal money without being caught, how to commit this crime, that crime, whatnot. Yeah? So that's completely unguarded and even tuned to be efficient in that. Of course, there are criminal gangs, but of course there are states that actually aim at doing bad things to us. I would say that some of the maybe smaller totalitarian Asian states, to give you some example, actually have massive operations to break into people's computers and steal money and to do all sorts of scams. And I will not share more details, but things like that do happen. What's the intent? Almost all, majority of that is financial. There are so many ways how to earn money. There is, of course, political manipulation that is at play. In extreme cases, it is also about personal harm, but that is much less common, except of, let's say, defamation campaigns on Facebook, or we have examples of what we call dangerous games. On YouTube, you can find videos where youngsters are instructed to play a game, and some really dangerous game, like, okay, who can climb up the highest roof in the town, or something like that. Yeah. So and these things, part of my job is actually my team's job is to scale the internet and search for such things, discover them, and eventually what it does in the products is that we try to kind of kill the connection to such a content, but that's just one example. Now we are in the era of scams, so vast majority of the threats that you might experience are scams. So it's now not anymore about contracting a virus into your computer through an infected, attachment of your email or something. That still happens. And even it didn't decline in the number of instances that we see, but it was completely overthrown by by the emergence of scams. And scams, what I mean by that, here are examples: romance, investment, shopping, extortion, employment. Just to explain what I mean by that, employment scam means that someone falls to a fabricated advertisement, for instance, gets in touch with that prospective employer, and on the other side there is this scammer, or these days it can be an AI model actually, because they scale up these operations, these scanners. So if they can afford that, they install a number of these of models, and they just instruct them to act as persons. For most of us, you would recognize after a couple of exchanges that it's probably a model. But not everyone. For the scammers, it is enough if 1 in 10,000 falls for it, because they just need one person to send the money. Yeah? So that's easy. And then they would communicate with that person. Oh yes, these are the terms, and this will be the workabout, and all sorts of details. And so as to excite the potential candidate. And at the right moment, when the person seems to be really excited and really willing to somehow join that company, they would say something like, okay, so the real interview with our HR is, I don't know, in 2 days, and here is some little, I don't know, processing fee. Send $100 to this bank account. And that's it. That's the goal of the scammer. And the number of these things is really enormous and keeps growing. Here I show where it happens. So social media, primary source of these scams. Websites, apps, phone calls, it depends on the country. These statistics are from the United States, because this is where we primarily measure that. So, for instance, in the Czech Republic, phone calls don't play a role, but in the US, it's enormously important. Text messages in the US, I think the statistics is something like an average person might receive 1 or 2 scam text messages a week, something like that. It would be some kind of parcels or something. It's the same, like, okay, you will receive a parcel and we need you to pay, I know, something for, again, some kind of fee. Of course, with the scams, the problem is that artificial intelligence, like the language models and voice models, make it more and more believable for certain people. And the worst form of scams that you might experience, and this is something that is on the rise and will probably be with us in the years to come, social engineering. And what I mean is the scammers will work on you not just through a singular communication about a job or about something. It would be much more nuanced. It would be probably about establishing a friendship with you, talking about other things, and having calls, and having I don't know what. It's we already observe some of these types of attacks, which are much harder to recognize, for people who trust the internet, for people who are used to live on the internet and make friendships on the internet, etc., etc. They are more vulnerable to this. So the worst attack that I know of, we call it pig butchering. Unfortunately, I'm just sharing this internal code for that. That means really that the attackers use all sorts of cunning communications to gain your trust, and they do it over months. So they choose a victim and they communicate with the victim for 3 months to really build up trust, and then they strike. And in these cases, this is really about tens of thousands of dollars a case, which people may lose. So generally, as I'm explaining this particular attack, I can give you one advice. Because these attacks can come in form of your relative giving you a call. Oh, I'm in trouble, and I need your help, whatnot. And the call will be in the voice of your relative. And it might confuse you. The technology is now so good that the artificial intelligence models can be really like tuned with a little sample of someone's voice. So, and then it can be used to basically communicate with you in that voice. Plus, because people leave about themselves quite a lot of details on the internet, these models can take those details and again modify their true personality of that model. So you would have a call from something that would feel like a person, that would that would really for quite some time feel like your real relative whom you know. And here comes the advice. With your real members of family, agree on some code word that you know you as persons. And if you have a call like that, and you have the slightest suspicion that there is something wrong, try to ask for that. And you might reveal that. That's probably the best advice I can give, given these things. How often that happens, it's not like an everyday thing. So I don't want to make an impression that we are now all under severe attack of this type. But in the Czech Republic, we have so far, let's say the last month, we have seen maybe 2 or 3 such attacks. Yeah? So, and I expect them to be on the rise, simply because the technology that generates that generates those virtual personas is cheaper and cheaper and more powerful. I have been now talking about topics that actually cross between the world of computers, the internet, digital world, artificial intelligence, and our real world. And here's a number of observations that I have about the internet, which I want to somehow emphasize that people don't realize very often. That when you use the internet and when you communicate with people over the internet, or establish contacts, or share your information on the internet, these things are different from the physical world, definitely. Yeah? So there is no perfect way to make sure who is who on the internet. It is a design flaw of the internet from my point of view. But when internet came to be, no one thought about it as something as essential. So nowadays you have so many false profiles, so many generated profiles. It is on the rise. I think that when Elon Musk actually argued that he wants to buy Twitter, his first argument was that there is 60% of profiles on Twitter are actually generated, not real, and he wanted to get rid of it. It's definitely hard to verify what is true and not when you read anything on the internet, for multiple reasons, because it is relatively easy to hack information on the internet. So if someone publishes something, then someone else can hack it, but that's one of the problems. The other problems are many of the content on the internet is now generated again, like through AI. And AI makes mistakes, it hallucinates. It has one more very nasty property. The AI models that people use to generate answers are trained to give as good answer as possible in view of what you probably want as a user. That means that the model sometimes has a choice when it generates the answer. It has a choice, either to go for something which is more factual, or something that suits you more, because depending on how you asked for what you wanted. And the models always choose to what you seem to be wanting. So depending on how you ask the model, you can get a positive or negative answer actually. So there is another very, very important thing to know. That there is nothing like a verifiable truth in what you get. Probably it is good to somehow get the mindset that the internet will be probably mostly containing generated content. The word fake may be sometimes appropriate, sometimes not, because of course you want to generate illustrations, benign illustrations of something as part of your presentations or whatnot. This image is just a nice image. It probably is harmless. So the word fake depends on the, let's say, intent with which the content has been generated and published or presented. I'm just saying that we should better expect that by default almost all the content is somehow generated, or will be very soon. And in my team we are trying to work on technologies that will detect whether something has been generated or not. But I can tell you this is principally not possible. It is possible to some extent with some easier cases, but the case for manipulation awareness, I said that content on the internet, when we communicate, we often try to influence someone, and the borderline between communication, influencing, and manipulation, it's subtle and it's very difficult to tell. But what I want to somehow bring up here is awareness that most of the content on the internet might be biased and will be biased more and more. Either intentionally or sometimes unintentionally. And one thing that we observe when we analyze the internet, that's the comment about free services. I mentioned before that there is nothing like a free service on the internet. Although we all use various email providing services, like Gmail, I'm a frequent user of Gmail, for instance. We use maybe Facebook or some other social networks simply to connect with friends. And if you use the free email, a free account, what you really pay for is your private data. And what I mean by that, it's not like some secret data of yours. It's actually your responses to what the service shows you. In Facebook, if you click likes, that gives Facebook an extremely precise behavioral model of who you are. This is not well understood by most of the people, and that's why I'm bringing it up. This is about selling stuff to us. This is about targeted advertisements. This is how it all started. And that's a very interesting thing for me, because like nowadays I observe so many negative things on the internet. When you communicate with people, or when you look at some news and you look at the comments underneath, it's anger, dissatisfied people, and everything's bad, and so it feels like, oh, there must be something wrong. This is not the real world. And I think that I somehow understand where it comes from. Some time ago I thought that this was kind of artificially or intentionally imposed by bad actors. My current understanding is that it's actually an unintended byproduct of personalization.